Assalamu alaikum, myself Mohammad Ashar Khan 23T35 and I am going to discuss the tree traversal methods. First of all, we have breadth first search. In this method, we in this method we go in the form of levels starting from the root node A and then move horizontally. In this scenario, in the graph 1, we have the root node A and it has no subroot node, so we skip it and go towards the next level, which is B. In this level, first of all, we will add B in our order and then we will add C, and there is no further neighbor in this section, so we move forward towards the subchilds of B, which is D and E, and then we go to the subchilds of C, which is F and G. So this is the scenario and methods of tree traversal in breadth first search. If we take another example, which is the given graph, in this notation, first of all we will take the A and B, then we go to C and D, and then in the end we will go to E. So this is the breadth first search and its method to traverse in the form of trees. Now our next topic is depth first search. In depth first search, we will go in the form of one straight level. It work in a way like if we have this tree structure scenario. So we will go in the form that first we will move towards A, then its subchild B, and then B subchild, which is D. After moving towards the D, if it has no more subchild, then we move back to the B, and then if it has another child, which is E, we will traverse towards the E, and then moving back from to B. B is completed, then we move back to A is completed, then its subchild C. We will add C, then we will add F and move back to C, and then we will add G. So this is the depth first search traversal method. We have take the graph 2, which is this graph. So in this graph we will go towards A, then C, and then E, then move back to C. C have no subchild, so we will go back to A and then move to B. Then we will traverse towards B, add B in our stack, then D, and when it comes to E is already there, so it will stop. So this is the DFS traversal of this method, this tree. Now we are implementing our approach of BFS and DFS in Python code. First of all, we have written the script for this process. In this script, we are importing the queue first from the libraries. Then we have made the function of for BFS, in which we have defined the function which has parameter of the graph and start. First of all, we have made the variable visited, which is equal to set, and queue, we have made the queue and we have started it from the start, and we have also made an other variable which is right now empty, which is known as ordered. We have started the while loop, which argument is queue, which means that it will traverse throughout when the queue is empty. First of all, we have write that node queue dot pop left, which means that in the queue we use LIFO FIFO principle, which is first in first out, and we add from the right and pop from the left. So node.queue pop left, if node is not visited, which means that start of the node when it is not visited, so we have added that node. We have to visit that node and then append it into the our ordered section. Then we have to visit our neighbor as well, that if it is even added or not. If it is not visited, we will append it in the queue and then return it to the order. Then we have a DFS function. DFS function have arguments of graph, start, visited, and order. We have just from the beginning we have equal, the visited is equal to none and order is equal to none. If visit is none, visit is equal to set. If it is the start of the graph and we haven't visit any of the node, so it will start it and take it from the start and append it into the set order. Order is right now empty. We will add it to the start. order.append start, which means that node A, let's suppose we have a node A is at the root as a root node of our structure, so we haven't visited it yet. So when we start it, it will add into the set and then append towards the append it to the our storage area, which is order, which is the name of that variable where it is going to save. Then we have started a for loop for our neighbor in graph start. If neighbor is not visited, then the graph visited dot order, then the neighbor is added into that ordered section and then return. Then we have given the graphs, which is called one by one through these both functions and give the output, which is task 1 output and task 1 DFS output. Task 1 BFS output is this. We have matched it, it is working correctly, as well as DFS. We have also a graph 2, which is the same with in our assignment, and graph 3, which is the robot finding path, which is also same and correct. So this is it.